Exercise 1.1 of Class 12 NCERT book. Questions on reflexive, symmetric, transitive, and equivalence relations. Show that the relation R in the set of points in a plane. Set of points in a plane. Let's take many points in a plane. These are all points in this Cartesian plane. Many points. Now, some of those points will be related to each other. How will they be related? Here the definition goes. Given by the pair P, Q will be included in the relation if distance of the point P from the origin is same as the distance of the point Q from the origin. That means two points in this plane will be related only if they both have same distance from the origin. Obviously, the points lying on a circle will be at same distance from the origin. As we can see here, this point P and this point Q both lie on the circle. Their distance from the origin are equal. So this P and Q will be related. There may be many other points also related to each other. Distance of all points on this circle from the origin are equal. Hence, by the given condition, each point on this circle is related to every other point on it. P is related to Q, Q is related to M is related to this point which is not named. Now, let's take another circle. Here we have points lying on that blue circle also. So this S is related to this point is related to this point because they are all having equal distance from the origin. Likewise, this point A and point B are related because the distance of A from the origin is same as the distance of B from the origin. That is what the condition given in the question. Now we want to show this relation is an equivalence relation. Let's see. Every point P is related to the point P itself. We can say this statement is true. Every point P is related to the point P because point P and point P have same distance from the origin. Technically, this statement is correct. Point P and point P have same distance from the origin. So we can say P, P belong to the relation. P, P belong to the relation for every P. Hence the relation is reflexive. Now, for it to be symmetric relation, if there is a pair A, B belonging to this relation, there should be B, A also. Let's see. If A, B belong to the relation, we can say OA equal to OB, where O is the center. If OA equal to OB, why not we say OB equal to OA? Which means B and A have same distance from the origin. That is, pair B, A belong to the relation. So logically we conclude that whenever the pair A, B belong to the relation, we would be able to say pair B, A also belong to the relation. It follows the definition of the symmetry. Hence, the relation is symmetric. Thirdly, is it a transitive relation? To check whether it is a transitive relation, let us go by taking any 2 points AB which are at equal distance from the origin and 2 points BC which are at equal distance from the origin. With that is, let the pairs AB and BC belong to the relation, which implies OA equal to OB and OB equal to OC. From these two, we can conclude that OA equal to OC. That is, Point A and C are also at equal distance from the origin. Hence, the pair AC will be found in the relation. So, this relation is transitive also. Transitive because whenever the pair AB and BC are there, we are able to conclude logically that AC will also be there in the relation. Hence, this relation is reflexive, symmetric, and transitive. So, it is an equivalence relation. We have proved it is an equivalence relation. Now we need to show something further. Further show that the set of all points related to the point P, if P is not the origin, all those points lie on a circle passing through P with the origin as center. It is almost obvious, but we need to express it well. As we have already observed, distance of all points on a circle from the origin are equal. Hence, by the given condition, each point on a circle is related to every point on it. So, set of all points on one particular circle form a subset in which every element is related to each other. Elements on this green circle will be related to the elements of the same circle as all of them are at equal distance from the origin. Points on the red circle will be related among themselves as they are also all at equal distance from the origin. Hence, set of all points related to the point is a circle passing through P with origin as center because from the origin the distance is taken. It is an equivalence relation, and set of all points on a circle forms a subset which is an equivalence class. Every circle is an equivalence class. Every circle is set of points which are at same distance from the origin. Each of them is an equivalence class. Every equivalence relation divides a set into disjoint subsets whose total union is the set A itself. These subsets are called equivalence classes. Here, set of all points on any of these circles is one equivalence class.